Okay, salam alaikum everybody. So hopefully the recording will be clear for the students. So remember, last lecture we introduced Coulomb's law, okay, and we wrote that Coulomb's law, that the magnitude of the force between two, between two charged particles Q1 and Q2. So if we have Q1 and Q2 and the distance r, then we wrote this is equal to the Coulomb's constant K times Q1, absolute value of Q1 times absolute value of Q2 divided by the distance squared. Okay, and we started doing some examples using Coulomb's law, and so notice that the magnitude of the force varies linearly with Q1, so F is proportional to Q1. F is also proportional to Q2, so if you double Q1 or Q2, you double the magnitude of the force, okay? And is inversely proportional to 1 over r squared, 1 over r squared. So if you double the distance, you divide the magnitude between the two charges. If you double the distance, the magnitude will be divided by 4. Now, obviously, if you have only two charges and there is forces between them, as the charges are getting closer, I mean, let's assume they are attracting each other, positive and negative charge. If they are attracting each other, they will move, okay? So if they move, the distance will get smaller, and when the distance gets smaller, the force gets larger. So it's not a constant force in this situation. So if we have the charges are moving closer together, so this is R1 and this is R2, clearly F2, the magnitude of F2 is going to be larger than the magnitude of F1. But we will see in certain situations the electric field or the force is constant, and we will see those situations later on in this lecture. Okay, so let me start the Kahoot and ask you this question here. Okay, so let me go to the Kahoot. Okay, so please enter the pin and answer the question when I show it to you. Okay, so we're waiting for the players. Okay, everybody please. So the pin is 8422724. Yes. We have many students who are absent today. Okay, so let me show the question. Okay, I will give you half a minute to read the question and answer. You have the choices are A, B, C, or D. So half a minute. If you can, please move closer. Okay, so I will start the Kahoot. Next. So you will have 20 seconds to enter your answers. Ten seconds remaining. Okay, All right, so let's look. We have 10 correct answers and 15 incorrect answers, about the right number of the of students. Okay, so let's try to do this together. So 58429 is the one who answered the quickest, I guess. All right, so let's look at this. Okay, so rank the arrangement according to the magnitude of the net force on the electron due to the protons. So you can see the electron is on the left here. Okay, this is the electron, and we have the protons. These are the two protons. Okay, and so we want to determine the force, the magnitude of the net force on the electron, and rank them. So let's determine the force between this electron, the electron to the left, and the proton that is in the middle. It has to be a force of what? Attraction or repulsion? It's attraction, so different charges. So let me draw it like this. So let's call it this F1. All right. Now we have another proton that is also a positive charge, but it's further away, so we expect the force to be smaller. So let me draw it like this. Okay. So if we add the two forces here, if we add the two forces, they are in the same direction, we can get, let's say, approximately like this. So this is the total force on the electron. Okay. Let's do the next situation. Okay. So here we have the electron is between the two protons. The proton to the left, there is a close distance, which is d2. So let's draw the force here. Let's call it F1. The proton to the right is also pulling on the electron because they are opposite charges. So, but this is, let me draw this as a little bit longer. Okay. The force to the right is smaller because the distance is larger. Okay. And so if we add the two forces, they are in opposite direction, clearly we get the resultant to be pointing to the left. So it's a negative force. So this is the resultant force here, F. Okay. Now if we take the last situation, in the last situations we have basically a rectangular situation, and we have the electron at one of the corners. So let's draw the force. The force due to the proton to the right is going to be about this much because it's a further distance. For the attraction between the electron and the proton in the bottom is going to be larger because the distance is smaller. So if we add the two forces, this is a vector addition, not scalar addition, remember. So when we draw the force, we get this is the resultant force. So clearly you can see that the largest magnitude is for 1. Okay. The next one is 3. Okay. Assuming these forces are, so let me call this is F. Use the blue color. This is F1, F2. This is F1, F2. So F1 is always smaller than F2. This is what we will use. So you can see that the magnitude of 1, F in the case number 1, is larger than case number 3, and which is larger than case number 2. Okay. So this is a good conceptual question, and you have to remember that the forces are vectors, so you have to add them in vector way. Okay. So let's go to the next example. All right. Let me. Yes. So here we go to presentation mode. Okay, so this is the problem. We have two charges. One is a positive charge Q1, which is 8e, and one is a negative charge, minus 2e. The distance between them is L. And the question is, at what point, not infinity, can a proton be placed so that it is in equilibrium? What do we mean equilibrium? Equilibrium meaning the sum of the forces is equal to what? 0. So we want to place a proton Okay, so the proton is obviously a positive charge, so that the forces are in equilibrium. This is a very common problem, so we'll go step by step through it. The first thing is we have to determine in which region can we place the proton so that the force is 0. Obviously, we cannot place it along the y-axis. Let's assume this is the y-axis here. We cannot place along the y-axis at any position because it will never be 0. Because if you add the forces, they will have a component that is non-zero along the y-axis. So it has to be along the x-axis. Along the x-axis, we have 3 regions: to the left, the center, and to the right. So let's make a reasoning for each of these situations and determine whether the sum of the forces can be 0 or not. So let's take the first situation. If we place the proton in the middle, if we place the proton in the middle in this case, all right. Now let's draw the forces that are on this proton. Okay. So this is positive and this is positive. So this force is going to be a repulsive force. So let's call it F1. Okay. The electron is negative and the proton is positive, so there will be an attractive force. So they will attract each other. So the second force is going to be F2. Okay. They cannot cancel in this case. Clearly, they cannot cancel if we place the proton between the 2 charges. Next situation. Let's place the proton to the left. Okay, and do the same thing. Let's draw the forces and see if they can cancel. All right. So again, a proton and a positive charge, there is a repulsive force. This distance is close, so we expect the repulsive force to be large, F1. Okay. And we have an electron and a proton, and so there will be an attractive force, and the attractive forces will be weak because the distance is further away, so it's going to be an attractive force like this, F2. Okay, the question is, can the sum of the forces equal to 0 or not here? Can it be equal to 0 or not? Okay, so here, notice, thank you. Everybody signed? Yes, thank you. Okay, so notice that this charge, the magnitude of charge is larger and it is closer. So the magnitude of this force F1 and due to this charge is going to be always larger than F2 because this charge, the magnitude of the charge is 2e, so it's small and it's further away. So it's going to be this force F2 will be always smaller than F1. So they will not be able to cancel. Okay, thank you. واضح. This is clear, because the heavier charge is closer. So the force from the larger charge is going to be stronger than the smaller charge that is further away. Okay, so they cannot cancel in this situation. So no canceling, no. Okay, let's take the third situation. Okay, so now we place the proton to the right. Okay, and do the same thing. Okay, let's do the same thing. So let's start with this proton. Proton and proton, there is a repulsive force. This is a distance. The distance is large, so I expect the force is going to be small, F1. Okay, well, now this is a negative charge. Negative charge and positive charge, there will be attraction, so this is F2. Can these forces cancel? Yes, they can cancel. Why? Yes, this distance is larger, but this charge is larger also. Okay, so this is possible that and we will verify that. We will verify that F1 can be equal in magnitude to F2 in this situation. Okay. So let's take this situation. So this is the proton here. Okay. And let's determine the magnitude of F1. F1 is Q1 times the charge of the proton, which is E. So let's call it Q3. Okay, divided by the distance. The distance, let's call this X here. This position here is X. So that means this is the origin here. So this is X squared. Okay, so this is going to be, let's replace the values of the charges. This is going to be K8 times E, and the proton has E, so this is E squared divided by X squared. Okay, now let's do the magnitude of F2. F2 is K Q2 times Q3 magnitude divided by the distance. What's the distance? The distance is now X minus L. This is the distance here. Huh? So this is X minus L, X minus L squared. So let's replace the values. Q2 is what? 2E. So this is 2E times E, that's E squared, divided by the distance, which is X minus L squared. Okay? So now we're going to set F1 is equal to F2, so that they cancel. F1, magnitude of F1 is equal to magnitude of F2. So that means we can write K, let's write times 8 E squared divided by X squared is equal K times 2 E squared divided by X minus L squared. Okay, so we can simplify this. The K's will cancel. Okay, the E squared will cancel. Okay, and we end up, and we can divide by 2, so this will be, if we divide by 2, this will be 4. Okay, so we can invert this to solve for X. We can invert these two sides. So we end up with 4 over X squared is equal to 1 over X minus L squared. Okay, let's invert this. So well, we can just multiply. 4 times X minus L squared is equal to X squared. This is the equation that we have to solve. So this has two solutions. It's 4x minus L is equal to minus 2x, and 4x minus L is equal to minus x. Okay, so when we do the two solutions, we will find, let's see here. So 4x minus x, that's 3x. 3x is equal, so this is x is equal 4L over 3 in this case, and here. So 4x plus x, that's, let's see. Did we forget something here? Oh, so 2 here. Huh? This is yeah, here. So this is correct here. So here 2. Huh? This should be 2. We took the square root of both sides. Huh? So the square root of both sides. So this has to be 2. So this becomes so 2x minus x. That's x. X is equal to L here. Okay, and here 2x plus x, that's 3x, and 3x is equal to L is 2/3 of L. Okay, so which one can be correct? We said the proton has to be here, so this is possible, but this is not possible, because when you say it's 2/3 of L, that means the proton is here, and we verified that the proton, when it's between the two charges, the forces cannot cancel. Okay, clear? Any question about this? This is, by the way, a very common problem that is given in exams. So please make sure you know how to solve it on your own. Okay, so these are the solutions. Okay, here is another common problem. Two identical small charged spheres, each having a mass of 3×10⁻²⁰ kilogram, hang in equilibrium as shown in the figure. Okay, the length L of each string is 0.15 meters, and the angle theta is 5 degrees. So they gave us the angle theta, and find the magnitude of the charge of on each sphere. All right. So here we have remember, this is when we're dealing with forces, so we have to use Newton's law. And in order to use Newton's law, we have to draw the free body diagram and draw all the forces. So let's take one of the masses, or one of the spheres, and draw all the forces on that sphere. Okay? So let me use a different color. Okay? So we have the gravity. Let's take the one to the left. We have the gravitation force. So this is mg. Okay? We have the tension, T. okay? And we have the force of repulsion. These are two positive charges, so they repel each other with an electrostatic force, okay? So there must be a repulsive force, so this is Fe. Same thing, this one, if we want to also draw it on this one, this also has a tension T, has gravitation force Fg, and has a force Fe, equal in magnitude and opposite in direction, because there is a repulsive force, okay? So now that we have drawn the forces on, you can draw free body diagram if you want to, so we do this X, Y, X and Y, and let's draw the forces. Okay, so this is a point, this is mg, okay, this is a tension T, and since the angle theta is here, it's the same as the angle theta here. Oops. Okay, all right, yeah, that's what I was afraid of. I'm not sure. Yeah. Okay, so let me see if I can do this quickly. See, without the surface pro, I don't even have a board to write on. But let me pause first of all the recording. I'm recording. I thought I'm recording. I don't know. Oh, here. So let me pause the wait for me.